Okay, so in this video I am going to give a brief overview of a paper that was presented at the Systems Dynamics Society Conference in Washington, D.C. By Dennis Jacobs, and looks like his co-authors here, excuse the pronunciation, are Inge Blyenberg and Jaak Venix. Sorry for the pronunciation problems there, but the title of the paper is Supporting Decision Makers in Managing Stock Flow Problems, the Effects of Oral Feedback on Reasoning and Decision Makers. So I'll just read the abstract here real quick, and then we'll lay out the problem scenario. You will have an opportunity to pause the video so that you can try to solve the problem yourself with pen, paper, calculator, Excel, whatever you'd like. 15 minutes were given to the participants in this paper for the task, so you can do that as well. Also, a tape recorder was used to record kind of the reasoning process here, so of the participants. So this paper broadens the scope of traditional stock flow experiments because for the first time the focus is on the product and the process. By using a Think Aloud protocol, insights is gained into the reasoning process of 8 participants in the female professor system thinking inventory task. Knowledge is used to identify patterns and deficiencies in decision makers' ability to manage simple stock flow problems and to propose measures to improve this. The effects of elaborate oral feedback on the quality of participants' reasoning and ability to solve tasks are assessed. The experiment shows that the most important reason for failure in managing stock flow problems is decision makers' lack of familiarity with the concept of average delay time for determining the outflow of the stock. That's a huge statement there. Furthermore, the oral feedback is found to be effective for creating insight in simple stock flow problems, although the use of supporting tools like a spreadsheet is essential for gaining a full insight and for successful management of simple stock flow problems. Alright, so there's kind of an overview of the problem scenario. Here's what we got here. This is you for the problem. You're a consultant. That's the consultant, and you are in this problem giving advice to a Dutch university. Whatever. This is a university. Maybe yeah. Okay. So in this problem, you're gonna help them achieve their goal. Okay, make them happy. They are interested not only in your advice, but in your reasoning process. So, help achieve goal. Interested in advice and reasoning process. Okay. So that's the scenario. Here's the problem's initial conditions. Okay, we're going to be looking at professors at the university. Right now, well, there's always going to be 300. Initially, male profs is 267, female profs is 33. Okay, I think that's like 11%, and then this would be then 89%. Okay. The average time a prof stays at university equals 10 years. Alright, so think about that one. And then each time a prof leaves, she is immediately replaced. So your job is to find the constant higher rate of female profs to implement for 15 years so that a 50-50 ratio is achieved. No, sooner, no later. Okay, so you say it's 2011 by 2026. You need to hit 50-50 goal. Okay? That should be all you need. Constant hire rate. So what's the rate of female professors? Okay? So there we go. Now would be, if you want to do this experiment yourself, pause video, crank away. Excel, pen and paper, calculator, whatever you'd like to do. All right? We'll leave this up. Okay, pause video. All right, welcome back. So, hope you had fun with that. Not as easy as you thought, I'm sure. But now, what we're going to do is use a systems thinking approach to build this model, and to use graphs and tables to play around with the hire rate, using the stock and flow structure to find what it needs to be so that we reach our 50-50 ratio at the 15 years. Okay, so I've downloaded an iThink trial. iThink or Stella, whatever you want to use, basically the same thing, but we're going to build this model here. It's from his paper. So I'm taking it from page 6 of the paper, and the equations for the model are in Appendix C. Okay? It's a pretty straightforward model, you'll see. Alright. So we got two stocks here. One's going to be male profs, the other one's going to be female profs. Obviously, we're going to have an inflow of female profs being hired and an outflow of female profs leaving per year. Same with male profs. Okay, now we're going to add all the converters so that we can enter the math that's going to support this model. Okay. So this is going to be the appointment rate. This is going to be average years working. We're going to connect our appointment rate up to the inflow. This is female hired. It's going to be male hired. Now is the wording. Pretty close. Okay. Firing female profs, or leaving, we should just say. Profs. This is the average time. We know this one, that's 10. We'll go to the model layer here. That's 10. We can set our run specs with Control-Alt-R. We'll go out to year 16 so that we can see the 15th and 16th year. That's fine. Average time. Okay, the leaving is going to be a function of how many people are there in the stock and the average time for both male and female. Okay, so this is total profs leaving. This is going to be total job openings per year. profs leaving. Job openings, and those job openings are gonna be the feedback. Okay, so I think we got it here. So we've got the two structures, average working period. Yep. All right. So total profs leaving. It's just going to be the. Well, first, here's the big kicker. So leaving female profs, the way we do that is just it's going to be the female profs divided by the average time. Okay. Same with male. Male profs divided by the average time. And if you'd like an explanation of why that is what it is, it's in Dennis's paper. You can get a hold of Dennis this way. So total profs leaving. We're going to just put the two of them here together. Female profs divided by average time plus male profs divided by average time. Okay, we can put our initial conditions for the female profs and the male profs in there. 33, 267. Total job openings is equal to the total profs leaving. Female hired is going to be the total job openings times the appointment rate, and we should actually call that female appointment rate. Female appointment rate, because then, and we'll just put anything in there right now. Why not 50-50, right? We'll try that. Males will be the total job openings times 1 minus the female appointment rate for the male appointment rate, right? Okay, so I believe now we should have a working model. Alright, so now we'll come up to the interface layer. And let's put down a graph. And why not a table as well? Okay. Let's look at male profs, female profs, leaving, and sure, let's put that on there. That's fine. Alright, so let's just adjust the scales here. We'll go up to, it starts at 267, so we'll go to 300. Set that one, male profs, we'll set this one to 300. Leaving female profs, 0 to 300, sure. Leaving male, we'll go with 300 on this one as well. Appointment rate, now this is only going to need to be 0 to 1. That's fine. Alright, so we also like to see the thick lines, like that kind of helps. Alright, so let's make this a little bigger here. And what we really are going to be doing here is playing with our slider that we will make equal to the female appointment rate. We'll have a min of 0 and a max of 1. And we'll bring it down to the 2 decimal places for precision. So we'll start with 50-50, and let's run that. Okay, so The orange line in the middle here, that's constant female appointment rate. That's okay. We gotta bring this down to that precision. We'll see this as well. That's fine. Sure, why not? Sure, why not? Okay. Alright, so after your... Alright, so for the lines here, the red line you can see up top is the male professors. Constant orange line is the appointment rate, 50-50. Blue line, female professors. You can see in this example, year 15, we are not at 50-50 at the end, so this is not the right appointment rate, but that's fine. Leaving male profs, leaving female profs are the green and the pink down at the bottom there. So you can see up top the values are presented when you click and hold over the chart here. Why not make it a little bit bigger? Okay. Why not? Let me pin that down. And then sometimes the view gets wacky, but there we go. Okay, so now this is the model built to play around with it, and you can do whatever you like to read the paper to see what the answer is. Tables are helpful. We can put the same info on there. We can put the female profs, the male profs, leaving, and sure, that's fine. So then you can Control R, run it again, and you can see, and this is just an incredible tool to see in each year what are the values that you have. Look at it on your chart as well. So there you have it, systems thinking approach, very helpful in understanding the lack of familiarity with the concept of average delay time for determining the outflow of a stock. Very helpful. Thanks, Dennis.